Now that we have discussed least common multiple, let us now move to highest common factor. Again, as the name suggests, we have to find a highest factor of the two given numbers or three given numbers or whatever number of numbers are given. Again, let's just not blab about anything and let's try and we'll simplify this HCF or understand this HCF with the help of a very simple example. So this time I am going to use some big numbers and then we'll see how can we find the HCF. So the numbers which I am going to select are 10 and 12. So we need to find the HCF of 10 and 12. Again, the first thing I need to do is to prime factorize it. So 10 can be written as 2 into 5 and 12 right here can be written as 2 into 3. Now, HCF says that we need to find the highest common factor of the numbers which are given to us. The numbers which are given to me right now are 10 and 12 and I can see their factors lying around right here. So, if I talk about the highest common factor, well, I can definitely rule out this 5 and 3 because this 5 is not common to 12 and this 3 is not common to 10. And all I have left now is this 2 right here. So, we need to find the highest common factor again. I am repeating this because it is important that we know the importance of the word common, because definitely there is a 2 present in 10 and 12 as well, but there are 2 2's present in 12, but the second 2 does not exist in 10, and so we can cut one 2 out also, and now we are left with only 2, and so we can say that the HCF of 10, 12 is equal to 2. I think this example would have made things a little clearer in your mind. So let's now take one more example and then we'll discuss the different methods using which we can factor or we can find the HCF of 2 or 3 numbers. So the other example which I am going to take is 84, 210. Now let's prime factorize 84 first. So 84 is going to give me 2 into 3 into 7, that is, we can verify it, 4 into 3, 12, 12 into 7 is 84. Now let's find the prime factorization of 210. So 210 is equal to 2 into 3 into 5 into 7. And now let's find the common factors of 84 and 210. So since we have no 5 in the first number, that is 84, so I can simply cut out this 5. Now I have 3 as the common number in both, 7 as the common prime factor in both the numbers, and 2 as well, but only 1 2 is common in both the numbers. So I can cut out this extra 2 and I can say that the HCF of 84, 210 is equal to 2 into 3 into 7, that is 2 into 3, 6 into 7, which gives me 42. So the HCF of 84, 210 is 42. This method which we are using right here to find the HCF of two numbers is called the method of common factor, or it is also known as the factor method. That is, to find the HCF using the factor method. So let's discuss one more example and then we'll move on to the other method using which we can find the factor HCF of two numbers. And this time I am going to use 3 numbers and then we are going to see what is the HCF of all the 3 taken together. So the 3 numbers which I am going to choose is, well, first is 18, the other is 27 and the third one is 81. Again, we'll have to proceed the same way. We first have to find the prime factorization of all these numbers. So let's start with 18 first. So 18 is equal to 2 into 3 into 3. Let's move to 27 and 27 is going to give us 3 into 3 into 3. And then let's move to 81 and we know that 81 is equal to 3 into 3 into 3 into 3. Now let us try and find the common factors. Since 2 is only limited to 18, so we can simply cut out this 2. And now the only factor which is left to me is this 3. So let us now analyze the numbers of 3 in all these numbers. So we have 2 numbers or 2 3's in this 18. we have 3 3s. This means that 1 3 is extra in 27. So we'll simply cut out this 3 and to keep 2 3s common to both these numbers. Now what is left is the prime factorization of 81. Now I can see that in the prime factorization of 81 there are 1, 2, 3 and 4 3s. But all we need is 2 3s, and so I'll cancel the remaining 2 and will only include these 2, and so the HCF of all the 3 numbers, that is 18, 27 and 81, will be equal to 3 into 3, which is equal to 9. And hence we can say that the HCF of 18, 27 and 81 is 9. The next method by which we are going to find the HCF of two numbers is the long division method. Now before starting with it, let me tell you one thing about this long division method. It is going to bring out the memories of your childhood. And why is that? Well, I don't know why is that, but we'll see when we'll discuss this method. But those memories can be happy memories as well, or it can be haunting memories as well. That depends upon how you take it, but one thing which I can make sure is that those memories will play a huge part, a huge role in here in the understanding of this method. So I'm sure you might be aware with this sign. Yes, it's the division sign. So we can definitely find the HCF of two numbers using this division sign as well. So let us start with very simple example. Let us try and determine the HCF of two numbers which are 6 and 14. Now if I have to find the HCF of 6 and 14 using the long division method, the greater number as usual will go under this division sign. Now this 6 will be our divisor and then we will proceed further. So when 14 is divided by 6, we obtain 2 as our quotient and we get 12. The remainder is 2 and this division continues further. But how is this going to continue further? It continues further till it will reach the point where the remainder will become 0. So our next divisor will now be this remainder and our next dividend will now be this 6. So I can now divide this 6 from this 2 here. So if I divide this 6 from 2 here, I can say that I will get 3 here, and 6 when subtracted from 6 will give us the remainder as 0. And so the HCF of 6, 14 is 2. Now I know everything happened quite fast here, so let's just slow down the process. Well, let's just reverse back and slow down the process and understand it step by step. So I first considered two numbers of whose HCF I needed to find. So the numbers were 6 and 14. The larger number became our dividend and the smaller number became our divisor. When 14 was divided by 6, the least number, or which was a multiple of 6, was 12. So we obtained the quotient as 2 and the remainder as 2. This remainder 2 will now become our modified divisor and our modified dividend will be the previous divisor, that is 6 right here. So this 6 will migrate from here and will make a transition here. That is, the 6 will become a dividend from the divisor and this 2 will become a divisor from the remainder. Now this 6 will be divided by 2, the quotient obtained will be 3 and 6 minus 6 will give us the remainder as 0. As I have already told you, we have to proceed this way until we reach the point where the remainder is 0, and since here we have got the remainder as 0, so the divisor at which place where the remainder has become 0 will be considered as the HCF of the two given numbers. So I hope the process is now clearer to you. Let us take one more example, and it is you who will now be helping me to solve this problem. So we'll take one problem which we discussed earlier. In fact, we are going to change it. So the numbers will be 84, 105. Well, we discussed 84, 210 and 105 earlier also. So you can consider that as my favorite example. So again, the larger number is 105 and the smaller number is 84. So 105 when divided by 84 give us the quotient as 1. Now this 84 will come here and 84 when subtracted from 105 gives us 21 as the remainder. Now what do we have to do? Now this 21 will become the divisor, will become the new divisor, and this 84 will become our new dividend. So we'll write this 84 right here, and now we will divide this 84 from this 21. So 84 when divided by 21 gives us the quotient as 4. We'll now have 84 in the subtraction, and 84 minus 84 will give us 0 as the remainder. So 84 when subtracted from 84, since gives us a remainder as 0, we can say that HCF of 84, 105 was 21. Let us now take one more example. Let us now find the HCF of 36 and 84. Now again, the larger number is 84, so it will come under the divisor sign, that is, it will become the dividend, and 36 will become our divisor. The quotient will come out to be 2, and we will have 72 right here. So 84 minus 72 will give us 12. Now this divisor will migrate here and will become our new dividend, and this 12 will become our new divisor. So this 36 when divided by 12 gives us 3 as the quotient and 0 as the remainder. And since the remainder is 0 and we have reached the point where we needed to find or make the remainder as 0, so we can say that the HCF of 36 and 84 is 12. Let us take one more example and solve it using the long division method. The only difference will be that this time we will be using 3 numbers instead of 2. That is, this time we will be finding the HCF of 3 numbers using the long division method. So my example, or the example which I am going to consider, is 136, 204 and 476. Now let us see the HCF of these numbers using the long division method. The first step is to select any 2 numbers of your choice. So which 2 numbers do you like? Well, I like 136 and 204. So I am going to take 136 and 204. So by long division method, 204 will become my dividend and 136 will become my divisor. The quotient will come out to be 1, because 136 into 2 is going to give me a much larger number than this 204. So this 136 will come here, and upon subtraction it is going to give me 68 as the result. Now this 68 will become my new divisor and this 136 my new dividend, and upon division the quotient will come out to be 2, and 68 into 2 will give me 136. So I can say that 136 minus 136 is going to give me 0 as the remainder. Now I have reached a point where the remainder is 0 and I have to take forward this value now. Since there is one value still left to be solved with, so we are going to take 68 and this 476 in consideration now. That is, the HCF of the 2 numbers is basically taken or proceeded further with this third term to calculate the HCF of 3 numbers altogether. So we will now take this 68 and 476 in another long division. This 476 will become our dividend and this 68 will become our divisor. Upon division, you will see that 68 into 7, that is 7 times 68 is going to give me 476 as the result, and so 476 minus 476 will be 0. That is, we will reach the point where our remainder will again become 0. And since our remainder has become 0, so this 68 right here will become our HCF, and hence we can say that HCF of 136, 204, 476 is equal to 68.